This is the AP Calculus BC 2022 exam, problem 1. A calculator is required for this part of the exam. So we can start by reading the problem and analyze part A. So the problem is saying that from 5 a.m. to 10 a.m. The rate at which vehicles arrive at a certain toll plaza is given by the equation a of t equal 450 times the square root of sine of 0.62 t, where t is the time of hours after 5 a.m. And it says that traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. Part A is asking to write but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m. to 10 a.m. So since it's giving us the rate at which vehicles are arriving at the plaza, we're simply gonna write the integral from, it says from 6 a.m., which is at t equal 1, so from 1 to 5 of a of t dt, which is going to give the total number of vehicles that arrived during that interval of time. So we're just gonna substitute a of t, so we're gonna have the integral from 1 to 5 of 450 times the square root of sine of 0.62 t dt. So now we can move on to part B, which is asking to find the average value of the rate in vehicles per hour at which vehicles arrive at the plaza, still in the interval 1 to 5. So we know that the general formula is the average rate is equal to 1 over b minus a times the integral from a to b of our function f of x dx. So now we're gonna substitute in terms of the problem we're given, and we're gonna have that 1 over b is gonna be equal to 5 and a is equal to 1, so 5 minus 1 times the integral from 1 to 5 of a of t dt. And we just kept solving, and then we'll plug in everything in our calculator, and we're gonna find that is equal to 375.537 vehicles per hour. So now we can move on to part C, which is asking if the rate at which vehicles arrive at t equal 1, so 6 a.m. at t equal 1, is increasing or decreasing. So since we're talking about, since the question is asking about increasing, decreasing, we can immediately think that this is going to ask for a first derivative of the equation given, and this is precisely what it's asking for. So what we're gonna do is, so we're gonna take the derivative of, so it's gonna be a prime of t at t equal 1, and since this is a calculator part, we're just going to plug everything in and find that it's equal to 148.947. So now, since we found that a prime of 1 is greater than 0, the rate at which vehicles are arriving at the toll plaza is increasing at time at t equal 1. which would be at 6 a.m. So now we can move on to part D, which is saying that a line forms whenever A of t, so the rate of vehicles, is more than 400. And the number of vehicles is given by an equation n of t, which is the integral from a to t of a of x minus 400 dx. And he's asking to round to the nearest whole number and find the greatest number of cars in line at the toll plaza in the time interval from a to 4. So we know that a line begins to form when a of x is equal to 400. So what we're gonna do is we're gonna find the intersects between a of x, the function a of x, and 400. So we found that intersects in 2 points, a equal 1.469, and a point, another point that we're gonna call b, which is 3.560. So now we're gonna use the equation that is given for the number of vehicles, and we're gonna say that the maximum number of cars is equal to n of t, which is equal to the integral from a to b of a of x minus 400 dx. And now we're gonna plug in the values we just found. So it's gonna be the integral from 1.469 to 3.560 of 450 times square root of sine of 0.62 t minus 400 dt. And now we're just going to use a calculator and find that is equal to approximately to 71.187, which we're going to round to 71 cars. So this was problem number 1 from the AP Calculus BC 2022 free response part A, and I hope you liked it.